flux capacitor that's firing up here on the smart board, we have dealt with this wing right here. We've dealt with this wing right here. So today, we're going to deal with the third and final branch of my flux capacitor, which is the volume of a gas. And in parentheses, it says STP. Now, what that means, ladies and gentlemen, is that this has to be at certain conditions that we call standard temperature and pressure. That's what STP is. Standard temperature and pressure. And at standard temperature and pressure, the standard temperature is 0 degrees Celsius. Okay? The standard pressure is 1 atmosphere of pressure. So at those conditions, we know the volume of a gas. Now, did it say the volume of a liquid? Does it say the volume of a solid? No, it only says the volume of a gas. So we are only dealing with gases here. So, at standard temperature and pressure, 1 mole of any gas has a volume of 22.4 liters. So, 1 mole of oxygen gas at STP, 22.4 liters is its volume. 1 mole of methane gas at STP, 22.4 liters is its volume. 1 mole of nitrogen gas at STP, 22.4 liters. So 1 mole of any gas at standard temperature and pressure is 22.4 liters. So when I set up my conversion box for this particular one here, as I'm following my green arrow down, I need moles to cancel, so 1 mole is on the bottom, 22.4 liters. This is my value on the top of my conversion box. Now, on the little orange arrow down at the bottom, what's that going to be? I'm just going to invert my boxes, right? I'm going to invert my box, so the bottom's going to be 22.4 liters, and the top's going to be 1 mole. So now I have my flux capacitor completed, don't I? What I'm going to do is we're going to work some problems on the molar volume. So here is our first example. Now it says convert 6.85 liters of methane at STP to moles. I'm going to start out writing what is given to me. 6.85 liters. You remember what methane is? It's one of those special ones that I told you just have to memorize what it is. Remember? This is going way back to molecular geometry. That's ammonia. That's close. That was one of the 3 I told you to memorize. Ammonia, NH3. Okay? It's a hydrocarbon. It's a hydrocarbon. Methane. Methane CH4. Commit that to memory again, folks. Commit that to memory. Now, in terms of my flux capacitor, where am I starting at? I'm starting down here. Volume of the gas at STP. Okay? So, I'm taking that volume and I'm going to moles. I'm going up to moles right here, correct? So I'm going to use this value right here. 1 mole over 22.4 liters. So I come back and I make my conversion box. 1 mole of methane gas is 22.4 liters of methane gas. Do I get a value to cancel? Here I have liters. Here I have liters. So now, what have I converted this to? What's my label? Moles of what? Moles of CH4. So how am I going to get my value? I'm going to take 6.85 and I'm going to divide that by 22.4. It's going to give me a value. How many significant digits do I have? I have 3 sig figs, so I'm going to get a value of 0.3006. Not too tough, was it? I'll give you a second. Now this is telling me that I have 2.12 liters of carbon dioxide at STP. And I need to convert it to moles. So this is just like the last example that I have. I'm at the volume of the gas. I need to get to moles. So as I follow that blue line now up, I'm going to have a conversion box of 1 mole carbon dioxide equal to 22.4 liters of carbon dioxide. I go back and look, do I get a cancellation of my labels? I do, because I have liters, CO2, liters of CO2. So I have now converted this into what? Into what? Moles of carbon dioxide. I go through and I do my math. I take the 2.12 divided by 22.4 to give me a value with 3 sig figs. It's going to give me the value of 0.00946. That is 3 significant figures. Put a box around my final answer so Mr. Braun can figure out where your final answer is. We okay with that? Give me a thumbs up here. Okay. Good. Let's go to another example. I'm going to give you a second to copy it. My question is, what is the volume of 0.421 moles of uranium-6 fluoride at STP? Once again, I'm going to write down my value that I'm given. 4 to 1 moles of uranium-6 fluoride. Remember, the Roman numeral tells you that the uranium is going to be a 6+, so I need fluorine. There's -1. I need 6 of them. Now, for this particular one, I'm given moles, and I need to follow the green line down to get my volume of a gas at STP. So the value I'm going to use is right here. 22.4 liters over 1 mole. I bring it back. I set up my conversion box. 22.4 liters of UF6 is equal to 1 mole of UF6. So now, I look and I get a cancellation of moles of UF6. I've converted this into liters of UF6. I take the 0.421 and I multiply it by 22.4, and it gives me, with 3 significant figures, 9.43 liters of uranium-6 fluoride. Now, what I want you to do, I want you to work this one on your own, and then I'm going to work it up here on the board. So work this one in your notes on your own. I'll work it up on the board. We'll see how you did. All right, here we go. 11.8 moles of nitrogen. Remember that nitrogen is a super 7, right? It should not matter right here. Okay, but just remember that nitrogen is a super 7. Put my conversion box up. What do I want to cancel? Moles of nitrogen. So I put that on the bottom. I know that 1 mole of nitrogen at standard temperature and pressure is 22.4 liters of nitrogen. Do I get a cancellation? Absolutely I do. I get my moles of nitrogen to cancel. So, I am going to take my 11.8 moles and multiply it by 22.4, and it's going to give me a value. That is not right. Did not put it in my calculator right. I had 1.8 instead of 11.8. It's going to give me a value of 3 sig figs, 264 liters of nitrogen. Give me a thumbs up on that. We get it? All right. Wonderful, ladies and gentlemen. That's right there is mass to volume, moles to volume. Okay?